think we're going to try and do the generation of chunks asynchronously now. So what I'd like to do is I'd like to sort of, well, we're going to have to be able to detect, well, first of all, we're going to kill off this sphere code. Don't need that anymore. And this dies. But what I'm thinking is we want to give a chunk a version so that we know how far along we are. So every chunk now has a version field, which gets incremented every time that chunk changes. So we are going to start by initializing version to 0. And then we are going to add a generate function on the chunk. So that we can call that separately to generate this chunk. So what we are going to do is I want to have chunk generate, and that is basically going to be this chunk of code with the added change that we are going to increment version at the end. So when we just create this instead, what I want to do is just to make sure, I want to run through and set everything to be air. So this is the initialization code, and we're going to do it that way around. There we go. So we can now call generate separately and have it generate the terrain. So right now, that's not really going to happen, just because. But what I do want to see is that this is a little bit faster, and it just generates empty. It's not particularly much faster, which I think is interesting. So definitely not using my CPU time on what I thought I was using it on, which is interesting because it's definitely empty. You can also see that we're printing a lot of empty index buffers, which is what we'd expect. So I wonder where we're actually using the CPU time then. Interesting. Because it could either be generating the chunks, and it's kind of hard to say because we don't really get any output while the script is or the program is running. We only get it when we return to the browser between every main loop. So that makes it a little bit difficult to figure out what's going on exactly. I mean, it doesn't seem like each frame is taking that long. Oh well. We need to get this code out of the way anyway. So what I'd like to do here is in the main loop, we want a static standard vector iterator. I'm going to do a quick little block here. So this is the current generator. And what we're going to do is we're going to take our chunks and we're going to take the first one. When we initialize it, then if our generator is not past the end, so if we've not generated the last of our chunks, then we are going to take this. We are then going to take this chunk and we're going to ask it to generate. And then we are going to go on to the next chunk for the next tick. So now every chunk will sort of be generated one tick at a time. Now for the chunk renderer, right now we generate the vertex buffer and then we run all of this code to set up our faces in order to put the data or the buffer. To populate our index buffer so that we can actually render it, we need to move this into a separate function that we can call multiple times as well. So it is going to get a void generate as well. Or rather, we have generate vertex buffer. I think we're going to have one called generate index buffer. And then, yeah, we're going to keep this private. What I'd like to do is also save a size T chunk version. So when we create our chunk here, or our chunk renderer, we need to create the generate index buffer function here, because it is going to do all of this stuff. It's not going to worry about the vertex buffer, but it is going to worry about a lot of other stuff. At the very end, what I want to do is I want to save the chunk version here to be the same as our chunks version. And my ability to spell chunk has not gotten better. So when we initialize here, we are going to call generate index buffer so that it's created. And that should set the chunk version as well. And then every time we call render, then if the chunk version is different from whatever our chunks version number is, i.e. the chunk has been changed, we are going to call generate index buffer. And that should allow us to update that. Version is a private member of chunk. Yeah, we probably want to do something like get version here. So let's go for our chunk here. There we go. We have a size T get version. In fact, for this one, we are going to inline it. So it's going to be inline get version. Return this version. Semicolon. Yeah, seems weird. Inline can only appear on functions and non-local Did I put a space here? I think I put a space here. There we go. That explains a lot. And we are, of course, const because we're not changing anything. One more time. Oh my god. So what have I been doing for the last hour? No, I've been adding this version field here, a function to get that version. Then in the chunk renderer, we factored out all of the generation of the index buffer from our chunk renderer over into a generate index buffer here, which now contains all of this code. At the end, it now updates the local chunk version, which is the version we have an index buffer for. And if that ever doesn't match when we try to render it, we generate the index buffer. So hopefully now we'll generate the chunks one at a time. Give it a go. So every frame should result in the generation of one more chunk. Now we're still using a lot of time starting up here. My guess is that the problem here is that we are actually pre-generating all of the chunk structures. We should probably wait with that and only do that once we're ready to show stuff. So you can sort of see that it's now generating chunks a little bit at a time here as we move up and around. So this is actually what sort of the terrain looks like as it's being generated. I mean, it's always fun to look at stuff being generated like this. Considering we might want to increase render distance. And another little crash. Firefox really does not like me today. Anyways, we'll go. Grab that one. So I was talking about not creating all of these up front, but trying to split them out in time. And I think we're going to try and do that. So rather than creating them all right away, what I'd like to do, and that's going to be a little bit of work, is instead of doing this, what I want to do is I want to have a static int x initialized to minus radius. Now I think we're going to do it sort of one Y layer at a time, just to do it interestingly. So as long as y is less than or equal to radius, which is of course not a true radius, it's just sort of a practical name because it's sort of a half side of a cube. We're going to increment y. And in addition to this, after emplacement, I believe that emplace returns a reference. Luckily, we have a reference manual. So we're looking at a vector. We are looking at emplace back. Since C++17, it returns a reference. So, and we're 17. We're working with C++17, so I should be able to call generate directly on the result. I hope. Nope. So we either don't have a new enough version of the plain compiler or something else like that. But this will, of course, be the last element to have been added. So what we can do is we can grab reverse begin, and then we can ask that to generate, like so. Just try and compile that. And switch over here and try and show that. So that is also just slightly expensive. Very expensive. So rather than doing it this way around, which is massively slow, what we want to do is we either want to do it one chunk per frame before, or we want to do it sort of one column at a time. I think we're going to try one column at a time. So that means we initialize x and z to minus radius. Then we are going to loop over the y, going from minus radius to radius, incrementing y along the way. Now, having done all of this, we need the right conditions. So as long as x is less than or equal to radius, we want to do this. Now, to make things interesting, what we're going to do is we are going to increment Z at the end. If Z becomes greater than the radius, we are going to set Z to minus radius and increment X. That should do one column at a time. And if that doesn't work, we'll just do one block at a time. So we've compiled. And switch over here. Refresh. Man, Firefox is having a hard time. Very hard time. Should probably have hit stop it at that point. Okay, if we start a new tab, kill off that. Okay, I can't even, there we go, killed off that tab. Let's try and see what we can do. So if we pull up Project Longshot here, it's still relatively slow as it tries to generate one column of terrain at a time, but it's actually kind of doable. So I think we want to change this over to doing it one single block at a time. So we are going to have all of these like this. So we are going to add one single chunk. Then we're going to add the chunk of it. And then when we get high enough, we're going to reset the height and increment the Z. And once Z gets high enough, we reset Z and increment X. So we're going to try that. Great. So over to the browser again. I'm going to want to stop that script. And that was not exactly what I wanted to do, but that was what happened. Get the browser back. There we go. And one more time. I'm going to start up Project Longshot. And now we can actually be somewhat interactive with it, as it, even though it's generating terrain. There are some rather big drops. I suspect that might be reallocation of memory, because that would probably require copying a lot of memory back and forth, because every chunk allocate or has enough memory in it to actually sort of how should we say, it has enough space in it to store all of its data. So chunks are actually relatively big, and we're actually storing a lot of them. So what we might want to do here is, just to make sure that we have enough space, is to ask this to reserve enough for, well, essentially radius times 2 plus 1. 3 times over, so that we don't get these breaks. At least for now. I can't spell reserve apparently. There we go. So we're going to try and reserve that much memory. And also for the render list, I want to reserve enough space that we can have the entirety of our current set of, oh yeah, that's a unique pointer. To have enough space for the entire set of chunks available right now. So, got to switch over again. So we've changed around so that essentially we reserve space here for our chunks. We're doing this a lot more often than we need to, but as soon as we've reserved once, it should be a no-op from there. And we also reserve for our render list so that it is big enough in the first go. And that compiles fine, so we are going to try that out. And Firefox is still not happy with me, so we're going to stop that script. And we are going to try this. So hopefully, now that we've reserved space, I'm not getting any weird stuttering, which is nice. So one thing we can sort of conclude from that, if anybody else is using Emscripten, it's really, really, really bad at copying memory around. But other than that, it works nicely here. Yeah, that was it. Now Firefox didn't want to play anymore. And of course, just to make life entertaining, I'm not getting any error messages from Firefox. It's just dying. Well, at least something works. So let's just clean up a little bit here. So right now we have a list of chunks that we just pre-generate ahead of time, and then we have a list of chunks we want to generate, and then we just sort of put these in and generate them as we're going. So what would be nice to do is sort of make it more dynamic so that we track where the player is or where the camera is, and then move according or generate the world according to that. So right now we have a camera class which has the position of the player and what we're looking from. And what would be good would be able to pull that out, figure out what chunks are around that, and then work from there. As that would sort of make it a lot more easy to, I guess, that would allow us to start working on an infinite map. And Panda, you've missed me creating the world's nicest looking map ever, or something like that. It's all stone, but it's nice. And a lot of crashes of Firefox. You've missed a lot of crashes. I'm actually almost professional at crashing Firefox by now. So let's try that again. There we go. Just switch over here because Firefox hates me. But so far we've sort of gotten a little bit of world generation going. Like this. That I'm actually really happy with, apart from the fact that we crash Firefox half the time. Maybe we should try and see what will happen. Yeah, it's definitely good for digging in. There's lots of digging to be done. I think what we're going to do is we're going to try and see if we can get away with maybe using a little bit less memory. thinking maybe the problem is that I'm asking for a gigabyte of memory and then Firefox is saying, hell no. So maybe what we should be doing is something like, I don't know, 256 megabytes of memory. I really hate these magic numbers, but that should be this number. Try and rebuild with that. And see what happens. I'm gonna switch over here. And we're just gonna kill off that tab. And yeah, Google is my calculator. So it seems we're still working with 256 megabytes of memory, which is good. So plan was to get onto actually working on having an infinite world rather than this little bit of world that we've got right now. Either that or try and figure out what to do about these floating objects, but I kind of like them. And I think we're... Every once in a while, my graphics card hates me. Actually, I just had a vague idea of what might be going wrong. I think Firefox isn't really crashing. I think I might be hitting Control W every once in a while. And yeah, you're looking at sort of 16 by 16 by 16 chunks being generated and rendered. So it's not per se loading or anything like that. It's generating them on the fly. We're just generating the same thing every time. So in theory, we can't generate an infinite world right now. That's not really working with the noise function. But yeah. Sort of, it's generating one chunk per frame, because otherwise you spend about 10 seconds loading the first time, and that's no fun. Because generating chunks like this isn't exactly the cheapest operation in the world. So we're getting these in. I'm gonna try and let it generate the entire thing just so we can see it. And I'm gonna try hard not to hit Control W. And I think that's it, actually. That's the world as it looks. I also vaguely remember there being a suggestion to add a skybox. That might also be a good thing to add soon. It's a little bit dark here. Basically infinite size. I mean, realistically, I'm sort of aiming for the 4 billion chunks by 4 billion chunks. I mean, something nice and small. Basically more surface area than the Earth has, because why the hell not? Whether we'll actually be able to do that, I don't know, but that's my goal. I like being a little bit ambitious with my projects. So yeah. When we get a little bit along, there's going to be some tricks to be able to do that. Stuff like positions of entities and the like are going to be a little bit interesting to represent. And we're always going to want to sort of keep the player centered around 0, 0. Otherwise, the graphics card and the graphics API, because they use floating point, are gonna, go big or stay in bed, exactly. if we don't keep the player sort of centered around 0, 0, then we're going to have a problem with the, I had the word a moment, yeah, with the graphics card and the graphics API, because they use floating points, and when floating point numbers get really big, they become very inaccurate, and that's sort of the main point where we actually use floating point. So what we want to do is we want to try and avoid using floating point as much as possible, which again was sort of the reason why here a moment ago when we were looking at the chunks position in the world, this get position here, I'm a little bit hesitant about actually returning a vector here, because that's a floating point number and this is sort of an absolute scale. We're saying this for this chunks x, y, and z. So if this x coordinate is like 2 billion, and we multiply that by 16, we get something like 32 billion. And if we return that in a floating point, it's going to have a precision of like maybe a kilometer between consecutive numbers. And so we kind of want to have the precision of a chunk being more than 1 kilometer, because a chunk is only 16 meters by 16 meters. I'm going for the same scale as Minecraft here, with one block being 1 meter. So that's the idea. So we're probably going to do this so that it's not like a get position of this chunk, but sort of get the position of this chunk relative to this. Because by doing it relatively and keeping the player near 0, 0, and we're only ever going to be rendering chunks sort of near the player, we should be able to maintain the desired level of precision. Because as long as the coordinates are like low, maybe like below 1,000, you have like sub-nanometer precision in floats, which is more than enough. Well, maybe not sub-nanometer, but at least like sub-millimeter. So yeah, at some point we're going to have to change this, but it works for now.